Hello everyone, welcome back to another video for the series. I'm InnoQ and today I brought a problem from USAMO. This problem was quite challenging and it took me a while to understand somewhat understand the problem compared to other ones. And I don't know why, but for some reason it feels like old tests are harder than current exams. And unfortunately, KMO is following the trend of the old ones. It just feels like that, and uh, that's why I'm planning to make more videos on KMO because the exam is approaching, and I don't have enough time to try other IMO USAMO problems, but to just roast KMO problems so that I can get um a grasp of it, and that's why, yes. But today I just brought a poem from USAMO because it just looked fun, and I think it was quite fun. So without further ado, let's get into it. So the proof is it starts so the proof is by contradiction. So for what am I doing? What? For the sake of contradiction, let A be the minimum value of n such that what mod A is not constant, meaning it has a period, or somewhat oscillating, because mod A is not constant. It has a since let K be the period let K be the period of the sequence. And the reason why there exists a period is because the complete residue system of mod A is finite, and that's because A is a finite number. Then we know that K must be greater than or equal to 1 because A should be greater than 1. And the reason why A is greater than 1 is because if A is A, then if A equals 1, these are all equal to each other, and that's not what we want. So A must be greater than 1, meaning K must be greater than or equal to 1. Now we know that the maximum value of K is A minus 1 because that's the number of complete residue, number of elements in the complete residue system. And this is obviously less than A. Holds. okay, because two is mod A is not constant, is periodic, is periodic, okay, wait, this one and this one, so he must also be periodic. And this is because, okay, so we know that this is periodic, and what is the factor that determines this to be periodic? And that is actually its period. So yes, so, and the factor that affects its period is like these exponents, right? So if this is periodic, then the exponent must be periodic but if it's not periodic, then mod A cannot be periodic because it will be a constant if it's not oscillating. Now, because if you found the if condition, let's do the reverse of it. So if this is true, then this mod, it's quite self-evident that this is periodic. Yes, because yes, that's true because we're counting. We can just think of it as counting these ones. No, actually, oh wait, it's mod k. So if this is periodic, then every value that we inserted will like start again from here. So we proved our if and only if condition. But we know that this is periodic. So if this is periodic, then let's think of it like this. Think of it as shifting. So this is therefore k is not constant. Okay, if this is not constant, then obviously as a result mod k is also not constant, because it doesn't, if this is constant then this must also be constant, but if this is not, then this is also not. It just doesn't really matter if you just exclude this. However, k is less than a, and a was assumed to be the least value of n, and that does not satisfy that is value of n such that is not constant. Does contradiction is present. And because this statement, where's our contradiction statement? Yes, because like a being the minimum value of n is not constant contradicts, it means this cannot be true. In other words, a cannot be the minimum value of n such that this thing is not constant. But a can be anything. That means this one, like this small n, is eventually constant all the time. Yeah, so this problem I think was quite challenging for me, and I think like the first kick is trying to use contradiction. The second one is like to connect the residue system and periods. I think this is the reason why number theory is quite hard. And yes, I think that was about it. But I don't know why, but it feels like it is hard to understand the solution at first. So I think overall it was a pretty difficult problem, and I hope you enjoyed it. Then like always, I'll come back tomorrow with another very fun and exciting problem. And as I mentioned, I'll be uploading more videos on KMO. So thank you and see you tomorrow. Bye.